In this example, we're going to find the length B and the two missing angles in the triangle shown. Because we're given two lengths with the angle between these two lengths, we're going to have to use the cosine rule. So, B squared is equal to A squared plus C squared minus 2AC cos of B, the angle between the two sides that we know. So in this case, B squared equals, well, A is 9.3, C is 8.9, minus 2 times by 9.3 times by 8.9 times by cos of 55. When we put that all into our calculator, we get B squared is equal to 165.7 take away 94.949, which carries on going. So B squared is equal to 70.75, and B is equal to the square root of this, which is 8.411. So that's our value for B, 8.411. We're now going to use that value, 8.411, to help us find the two missing angles. Now we've got three sides in an angle, we can use the sine rule. So if we try and find angle A now, we know that sine of A over the length A, which is 9.3, is equal to sine of the angle we do know, which is 55, over the length opposite that, which is our 8.411 that we just calculated. With a little bit of rearrangement, sine of A is equal to sine 55 over 8.411 times by 9.3, which gives us sine of A is equal to 0.905. So A is equal to the sine inverse of 0.905, and so A is equal to 64.9 degrees. Add that to our diagram up here, 64.9. And finally, we have to find angle C. We could use the sine rule or the cosine rule, but this time we're going to use the fact that C is the third angle in a triangle, so it's equal to 180 minus 55 minus 64.9, which makes C equal to 60.1 degrees. And that is how we use the cosine rule, the sine rule, and the angles in a triangle to calculate a missing length and missing angles when we know two lengths and the angle in between those two lengths.